In this video, we're going to talk about the weights of defensive players and construct a box plot with the given data. Here we have the weights of 19 different defensive players. So N is going to equal 19. We're going to use these weights to find the median of the data for question number 1. The median of the data represents the middle weight. In order to find the middle weight, we'll need to place these weights in order either from smallest to largest or the largest to the smallest. So here I have rewritten all of the weights of the defensive players from the smallest to the largest weight. Since there are 19 weights, we know that that is an odd number and there will be only one weight representing the middle data. So you could actually go through and eliminate the first and last measurement, and again eliminate the second and second to the last, and keep going through that process to find which one is exactly the middle. And it's going to turn out to be the 9th measurement. That brings us to the second 190 pounds. I'll label that with capital M representing the median of the data. We now are left with 9 measurements below the median and 9 measurements above the median. To find the lower and upper quartiles, we're finding halfway below the median and then halfway above the median. So halfway below the median, that is the lower quartile, represented by Q sub L. To go halfway above the median, that would be 5 measurements above the median. That's the 205 pounds. That's the upper quartile represented by Q sub U. For question 3, what is the inner quartile range of the data set? The inner quartile range is known as IQR. And that simply means we're going to find the distance between the upper quartile and the lower quartile by subtracting those values. So off here to the side, IQR is the upper quartile minus the lower quartile. Substituting in their numerical values, IQR would then be equal to 205 minus 173, and that gives us 32. So 32 is the IQR. In question 4, we're going to be making a box plot of the data. So in order to construct the box plot, we're going to be plotting the data concerning minimum value, maximum value, both of our quartiles, and the median. So our number line needs to go from 145, which is our minimum value, all the way to 280, which is our maximum value. So let's start off by drawing a line. We're going to need a pretty long line here. And under this line, we're going to write our values. So I'll probably start with about 140 pounds, and I need to go all the way to 280. So I'm going to count by tens, but I'm starting with 140. Now that I have all of the numbers written under the number line, I can make the marks associated with our quartiles, median, min, and max. The first mark I'm going to draw is the median at 190. So 190 is located here, and I'm going to draw just a short vertical line at 190. My next mark will be the lower quartile at 173 pounds. So if this is 170 and this is 180, then it's just a little below 175 right there. I'll mark an M for median and Q sub L for the lower quartile. My next mark is the upper quartile at 205 pounds. So that would be halfway between 200 and 210. So 25 is about right here. I'll label this as Q sub U for the upper quartile. To construct the box, I'm going to draw a horizontal line from the lower to the upper quartile, and then I'm going to draw another horizontal line at the top of these bars. Next is the construction of the whiskers. The whiskers are formed by placing a vertical line at the minimum and maximum values. Our minimum was 145, I'll label that min. And our maximum value was 280 pounds, so way at the other end. Again, I need to connect these vertical lines to the ends of the box. And this is how the whiskers are formed. And here we have our box plot. We've got our minimum value. I'll label the max. So those help to form the whiskers of the box plot. The box itself is formed by placing a vertical line at the median and vertical lines at the lower and upper quartiles. Connecting those with horizontal lines forms the box. So you'll hear this referred to as a box plot or a box and whisker. We're ready for question 5. Is the data set skewed to the left, skewed to the right, or symmetric? So in order to answer that question about skew, what we're really doing is comparing the distance from the median to the minimum and the median to the maximum value. Just looking at this, it's pretty much to scale. We can see that the whisker on the right is much longer than the one to the left. But there is a way to calculate this just to make sure, because sometimes it'll be hard to tell if it's actually symmetric or not. So if we start with the max value and subtract the median, we'll be able to know exactly what that distance is. Our max was 280 minus the median, which was 190. That gives us a distance of 90. Now let's compare from the median, subtract the minimum value. Remember to start with the larger number so you don't have a negative distance. So the median was 190 minus our minimum value of 145. That gives us a total distance of 45. So 90 is larger than 45. So we know that from the median to the maximum is the longer distance, and that is to the right. That means we have data skewed to the right. Now there is another way that we could determine which direction our data is skewed, or if it is in fact symmetrical. And since we are given some information concerning the mean is 192.5, and we know that our median is 190, we can make a comparison like we did earlier in this chapter. So this is called mean versus median. The mean was 192.5 and our median was 190. To compare these with an inequality or equal sign, we would have to say that 192.5 is greater than 190. So the mean is greater than the median, and that also confirms our data set is skewed to the right. In question number 6, we're looking for any outliers in the data. So again, we can make a calculation to determine if we have any outliers for our data. We're going to start first with the lower quartile and subtract 1.5 times the IQR. This will determine if we have any outliers at the lower end of the data set. So we need to make a little substitution here. The lower quartile was 173, and we'll be subtracting 1.5 times IQR. Remember, we calculated that already as 32. 1.5 times 32 is going to give us 48. So we're taking 173 minus 48, and that gives us 125 pounds. Looking back to our measurements, 145 is the lowest measurement. So we don't have any extreme values at this end of our scale. So none in this range. We do need to consider the upper end of the scale though, so we have to start with the upper quartile and add 1.5 times the IQR. So our upper quartile at 205 pounds plus 1.5 times 32, which was the IQR. Again, that value made 48. So this means 205 plus 48 gives us 253 pounds. Let's look back to the data to see if any of our measurements are 253 or more. 280 is the highest, so that is more than 253. 228 is not 253 or more. So only 280, that means we have one in this range, and that would be the 280 pounds. So the number we actually calculate for the upper quartile means 253 pounds or more, and at the other end, for the lower quartile, it should be 125 pounds or less. We didn't have any measurements in that range. So by finding that 280 pounds is an outlier, there's one more piece of information we'll need to add to our box plot. Typically, an asterisk is used to identify an outlier on the box plot. So at 280 pounds, that is not only our maximum, it is also an outlier. So I'll draw an asterisk at 280 pounds. Since 280 is an outlier, we'll need to adjust our whisker. So we're going to look back to the data set and find that the measurement directly before 280 pounds is 228 pounds. That means our whisker will actually stop at 228 pounds. So if I redraw that whisker, I'll need to erase the rest of this whisker. In question number 7, we are given the mean of 192.5 pounds and a standard deviation of 28.7 pounds. So we want to confirm our answer in question 7 using the z-score formula. So this just means we want to confirm that 280 pounds really is an outlier. So recall that the z-score is equal to x value minus the mean divided by the standard deviation. Our z-score then would be 280 pounds minus the mean of 192.5 divided by our standard deviation of 28.7. So using your calculator, you should come up with a z-score of 3.05. This represents just beyond 3 standard deviations to the right of the mean. And recall that more than 3 standard deviations in either direction from the mean would constitute an outlier. So this just confirms our answer to part 6, that 280 pounds would be an outlier. And finally, question number 8. What percentage of the measurements in the data set lie to the right of the median? And what percentage would lie to the left of the upper quartile? You might find it helpful to draw a line. The lower end of the line will represent 0%, and at the upper end, that's 100%. So think about the definition of quartile. Quartile will divide the data into 4 equal parts. So if we go from 0 to 100%, we need to divide this into 4 equal percentages. 100 divided by 4 is exactly 25. So that means we're going to divide these percentages from 0 to 100 into 4 equal parts, and each part is worth 25%. Halfway would be 50%. Halfway between 0 and 50 would be 25%. And halfway between 50 and 100 would be 75%. So we can go back and look at the question. Number 8. What percent of the measurements in the data set lie to the right of the median? The median is right at 50% because that represents the middle of the data. So to the right of the median would be from 50% all the way to 100%. So from 50 to 100, that is worth 50%. And the other question is asking about what percent of the data falls to the left of the upper quartile. Well, 25% would represent the lower quartile, and 75% would represent the upper quartile. So if we're going to the left of the upper quartile, that would be from 75% all the way back down to 0. So that would be 75% of the data falls to the left of the upper quartile. So I hope you find it helpful to draw this line, label where your median and quartiles are. The quartiles divide the data into equal parts, and that would be 4 equal parts. So that means each section is worth 25%.